Variance and standard deviation give us two values that characterize numerically the average amount of variability in a set of scores, in a distribution of scores. In order to be able to calculate variance and standard deviation, you have to know how to calculate sum of squares. And as your textbook explains, the term sum of squares, sometimes abbreviated just by SS, is shorthand for the calculations that we're about to do. And you're going to see that this is actually very simple to do by hand if you have a small set of scores. All right, let's do this together now. At the top, I've given you a sample little distribution of scores, let's say for a test of verbal ability given to six subjects, sorry, we have 6 scores, right? One subject scores 188, another subject scores 210, another subject scores 170, the next subject scores 205, next subject 221, and the next subject 206. Now the first thing that you have to do is you have to get the mean of this little distribution of scores. And if we add all the scores together, we find that they total 1,200, and you divide the total of the scores by the total number of values represented, which is 6. So you find that the mean of this population is 200. All right. Now, here is a table that's going to help you calculate sum of squares. First, we need enough rows for each of the values represented. And I'm going to put one more row so we have a special cell for putting the sum of values when we're finished. Let's enter each of the scores first. This is very easy. Notice you don't have to put them in any numeric value order. 205, 221, there are 6 scores. Now, to make this very easy, I want you to enter the mean of this little distribution in each of these cells. And this is just to make it very, very obvious to you what you're doing here. All right, now in this column, we're going to subtract x from the mean of this population of scores. So in the first cell here, we get negative 12, right? 188 minus 200 is negative 12. 210 minus 200 is 10. 170 is minus 30. 205 is 5. 221 minus 200 is 21, and 206 minus 200 is 6. Now notice something. Remember, what we're trying to do here is we're trying to get to a number that's going to give us the average amount of variability from the mean of all of these scores, of this particular set of scores. This is a very obvious kind of calculation to do, right? If you want to know the average distance from the mean of each of these scores, you take each score minus the mean, you add them up, and maybe divide by 6. But that's not going to work. If we add up all these numbers, this final number is necessarily 0, right? Let's try it. Here we've got 42 minus 42. Here we've got positive 21, 31, 36, 42. Minus 42 and positive 42 is 0. If you've done your calculations correctly, this column will always total 0, right? So we can't stop there if we want to determine the average amount of variability from the mean. We have to do something to these numbers that allows us to add them up, and then we'll see divide by the total number of scores. So we can square these, right? If you square 12, minus 12 times minus 12 is positive 144. 10 times 10 is obviously 100. Minus 30 times minus 30 is positive 900. 5 times 5 is 25. 21 times 21 is 441. And 6 times 6 is 36. Great. Now, if we add up all of these scores, we get a value of 1,646. Oh, good. A positive number. And we can do something with that, right? So the sum of squares for this little distribution of numbers is 1,646. Now that alone is not going to tell us a whole lot. That's just the first step in being able to calculate variance. Variance is just the sum of squares divided by the n, right? So in this case, the variance equals 1,646 divided by 6. And that number gives us 274.33. All right. Now this number, 274.33, that number alone is not in the same distribution range as the original values, right? If you look at 274.33 and you look at our original values of numbers, does it make sense to say that these numbers differed from the mean of the distribution by 274.33? No, that doesn't make any sense given this range of numbers, right? Why? Because we squared those values. So now we have to get rid of the effect of the square, is one way that you could say that, or we have to unsquare this, is another way to say that. And to do that, we just take the square root, right? So we get it back to its original range. And if you take the square root of 1,646 divided by 6, you get 16.56. So for this little distribution of numbers, the standard deviation is 16.56. And now if we look back at this original range of values, 56 makes a lot of sense. So that's how to calculate sum of squares in order to get variance and standard deviation. 3 absolutely critical concepts in statistics.